Hope everyone is doing very well. And tell me who has joined the session. And tell me who has joined the session. Okay. Wait a sec. So, hello everyone, welcome to BYJU'S exam prep. I hope everybody is doing very well and tell me who has joined the session. Now, today's session is going to be a very interesting session and also the continuation of a session that we have done in the yesterday's class. So, in yesterday's class, we have done the short circuit test and the open circuit test, right? Now, based on the short circuit and open circuit test, we have solved few questions over it. That was some was the medium level, but some was the higher level. So I hope you have enjoyed that particular session. Now in today's class, we are going to solve question on the clipper and clamper. But again, on the question of clipper and clamper, I will tell you the logic behind it using the short circuit and open circuit test. Okay. If you have done this topic, then you know the shortcut formula to find out the clipper and clamper waveform. Okay, that's a shortcut formula, you know, that's very good. But sometimes that shortcut formula will not work. If you're going to apply the shortcut formula everywhere to find out what will be the clipper output, what will be the clamper output, then that might give you a wrong answer. तो आज की क्लास हम क्या देखने वाले हैं कि शॉर्ट सर्किट और ओपन सर्किट टेस्ट को यूज करके कैसे हम क्लिपर एंड क्लैम्पर की वेवफॉर्म्स ड्रॉ कर सकते हैं. एंड ट्रस्ट मी गाइस, फॉर द इलेक्ट्रिकल स्टूडेंट्स, one question you are going to get definitely from this topic in your examination or the type of this question, and also there is a high chance for EC students to get question from this topic. So before starting a session, let me tell you that share the session among your friends so that more and more students can join the session and watch this particular class. And tell me who has joined the session. Wait a sec. Tell me who has joined the session. So let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. I'm Tech gold medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. Now, before starting a session, let me tell you, today the Joshi sir is going to give you a workshop. This workshop is very, very important for you. In this workshop, you are going to learn how to make your schedule, how to do the studies, how should be your mental balance when you are going to prepare for GATE 2025 examination. This workshop is going on live at 8 November, 7:30 p.m. on the app. So don't forget to register for it, and it's going to help you a lot. Trust me. Apart from that, we are going to launch our scholarship test for the GATE examination. This is going to be held on 11th and 12th November between 9 a.m. to 9 p.m. So if you haven't registered for it, I will advise you register for this and give the particular scholarship test. You are going to get 90% off on our programs. Good evening, Sai Kiran. Good evening, Sai Kiran. Okay, so we'll start our session. Let's start our session with first question we have. With the first question we have, let's start our session. So this is the first question we have. Read the question carefully, and try to solve it. We have options also. So, but first try to make the waveform by yourself, and then I will show you what will be the option here. Okay, try karo. We are going to solve the question using the open circuit and short circuit test, bacho. All the question on clipper and clamper can be solved using that particular concept. So we are going to see that concept thoroughly. So let's read the question. The equivalent circuit of a diode during forward biased and reverse biased condition are given. It's actually 0.7 here. Are given in a figure. In such a diode is used in clipper circuit of figure. What will be the output voltage V0? So we need to find out the output voltage V0. Okay. First of all, see the circuit here. What does this particular part of question showing you? This part of a question is showing you when the diode is forward biased. When the diode is forward biased, it has been replaced by a battery of 0.7. It means it's a practical diode. When it is reverse biased, it has been replaced by a open circuit. Okay, one thing we know here. You solved yesterday homework. Okay, I will discuss it. Whenever you solve the question, just give the answer in a comment section also. So if your answer is right or there will maybe some wrong, I will comment on that particular video. Okay. Now next point here you can see in the question it is mentioned that you have a clipper circuit. In the question it has mentioned that we have a clipper circuit. Now what is the meaning of clipper circuit? Clipper circuit means some part of input waveform is going to be clip. Some part of input waveform is going to be clip. That is the meaning of a clipper circuit. So, but that doesn't mean that your input signal will always clip. this is a type of a clipper circuit that according to the configuration we have a clipper circuit, but don't just use the shortcut blindly. You have to understand the limitation of a shortcut also. So don't use the shortcut blindly. The best way is to analyze the circuit very carefully, because these type of question will come for 2 marks, and easily you can give enough time in these type of question and do the analysis correctly. So how we can do the analysis? First of all, we use the open circuit test and find out what is the voltage across diode. Once I find out the voltage across diode, then I will have a conditions based on this. For this condition, what will happen? For opposite condition, what will happen? So all of these things we are going to see in this question. Okay. So let's see. So here you can see, first of all, what we can do, I can convert the practical diode into ideal diode. First of all, what can I do? I can convert the practical diode into ideal diode. Now I told you, to convert a practical diode in ideal diode, just replace a diode with a diode in series with a voltage source. So when you replace the diode with a series with a voltage source, it comes out to be 0.7. Now it becomes the ideal diode. Like this. Now it becomes the ideal diode like this. This is the input voltage. Across it, I want the output voltage, and the resistance R and R are same. Okay, this we have. Now what we have to do? We have to assume either diode is open circuit or a short circuit. I'm going to assume that diode is open circuit. Okay. So I'm going to assume here that diode is open. Diode is open circuit. Or you can say I'm assuming diode is reverse biased. So if I'm assuming that diode is open circuit, the circuit will form like this. This is the input signal. This is R. This is plus minus V0. The circuit will be like this. Now in this case, can you tell me what is the diode voltage here? In this case, can you tell me what is the diode voltage here? Think about it. Can you tell me what is the diode voltage here? For that, let's first find out the output voltage. Output voltage is equal to VI by 2. Why? Both resistors are in series, so we can apply the voltage division rule. So output voltage comes out to be VI by 2. Very, very simple. Now, if you want to find out a diode voltage, I can apply the KVL here. For a diode voltage, I can apply the KVL here. So let's apply it. So it will be minus 5.7 minus VD plus output voltage, which is actually equal to VI by 2 equal to 0. From here, diode voltage comes out to be VI by 2 minus 5.7. From here, diode voltage comes out to be VI by 2 minus 5.7. Understood this thing? How does diode voltage comes out? Once I have a diode voltage, what we can do? Once I have a diode voltage, I can say, for assumption to be true, diode voltage must be less than 0, because our assumption is that diode is open circuit. So diode voltage must be less than 0, or we can say VI by 2 minus 5.7 must be less than 0, or I can say VI must be less than 11.4 volt. So this is the first condition we have. That if input voltage is less than 11.4, so we have first condition here is that if input voltage is less than 11.4, output voltage is VI by 2. Okay? This is the first condition we have. So another condition will be the reverse of it. So for VI greater than 11.4, diode is going to be diode is going to be short circuit. So if diode is going to be short circuit, then output voltage is fixed. If diode is going to be short circuit, then output voltage is fixed. It does not depend on input voltage. So here output voltage is 5.7 volt. Okay. So we got two conditions. See very carefully. We got two conditions here. The first condition is that when input is less than 11.4, output voltage is VI by 2. When input is more than 11.4, output voltage is 5.7. Okay. Now check what is the input voltage given. So if you see carefully, input voltage is 10 sin omega t. Input voltage is 10 sin omega t, है ना? Input voltage is 10 sin omega t. It means the input lies between 10 and minus 10. It means the input lies between 10 and minus 10, and because of that, this second condition will not come in picture. This second condition will not come in picture. See very carefully. This is the input voltage. This is 10, this is minus 10. So the input voltage lies between 10 and minus 10, and according to a first condition, if input is less than 11.4, output is Vi by 2. So for the whole waveform, the input is less than 11.4, so output voltage will be equal to Vi by 2, which means 5 or minus 5. So what you have seen in this question, you can see in this question that they have given you the clipper circuit. But the waveform is not clipping here. You can see the wave shape remains the same. It means the operation of clipping is not happening here. Why? Because the conditions are not satisfied. So that's why I'm telling you, don't just blindly follow the shortcut method. You should understand there is a limitation for a shortcut method. So you have to do the analysis very carefully. Once you have to assume that diode is open, find out the voltage across diode. Then for the conditions to be true, you can do the work like this. Okay? It means which option is correct? Option A is the right answer. Otherwise, you can see in all the option B, C, D, you can see some portion has been clipped out, which is actually the working of a clipper. Understood this question? Yes or no? Tell me. And I can see today there are very, very less students. ओके शेयर करो, सेशन को शेयर करो अपने दोस्तों के साथ. क्या हो गया? देखो बच्चों, अगर आप लोग ऐसे सेशन पे नहीं आओगे ना, फिर दिक्कत क्या होती है, फिर हमें भी मोटिवेशन नहीं मिलता कि हम क्यों ऐसा फ्री इनिशिएटिव कर रहे हैं. फिर तो हम पेड कोर्स में करा ले, है ना. पेड कोर्स में हमारी जिम्मेदारी हो जाती है, तो वहाँ पे हम लोग पेड कोर्स में करा ले. बट जब फ्री इनिशिएटिव स्टार्ट होता है ना, ट्राई करो कि ज़्यादा से ज़्यादा बच्चा है. नाउ नेक्स्ट, ट्राई टू सॉल्व दिस क्वेश्चन. अ क्लिपर सर्किट इज शोन बिलो. Assuming forward voltage drop of the diodes. They are saying diodes, so they are talking about Zener diode as well as the normal PN junction diode. To be 0.7, the input-output transfer characteristic of the circuit is. We have to draw the input-output characteristic of this, which means, wait a sec. This is the options here. We have to find out what is the transfer characteristic between them. Always remember, transfer characteristic means output versus input voltage curve. Okay? So try करो एक बार, सोचो कैसे होगा. I will give you 1 minute to think about it. Question simple है. If you know the concept clearly, questions are very simple. Okay? Although this question has come for 2 marks, but concept अच्छे आपको पता होना चाहिए. First of all, you can see in a positive half cycle, Zener diode will be reverse biased, but the normal diode here will be forward biased. If I talk about which cycle? In a positive half cycle. Now this diode has a voltage of 0.7. So if diode is a voltage of 0.7, so when input become more than the 5.7 volt. Why the 5.7 volt? Because this is the 5 volt here and the 0.7 because of diode. So when the input is more than 5.7, then you can say that diode is going to be turned on. And when this diode is on, the voltage across this particular node or this particular branch will be fixed. The voltage across this branch will be fixed. This one point we know. And for this Zener diode to go into a breakdown region, the voltage across it must be more than 10 volt. Okay. So what we can say here, I can say when input is more than 5.7, what will happen? Diode is on. Diode will be on. Why the 5.7? 5 this voltage, 0.7 its drop. So when input is more than 5.7, the diode is on. When the diode is on, the circuit will be look like this. when the diode is on, the circuit will be look like this. Why? Here, Zener diode. If I talk about a Zener diode is reverse biased. In this situation, Zener diode is reverse biased. Okay. Sorry. We can say this is a 5 volt. This is 0.7. This is 0.7. This is 0.7. So this is 0.7. This is 5 volt. Okay. Here you have an input voltage. Here you have an input voltage. And here we have a resistance 1 kilo. Okay. Now see this point very carefully. See this point very carefully. Once the diode has been on, एक बार आपका diode on हो गया. Once the diode has been on there, the voltage of that particular branch is fixed. The voltage is 5.7. Since the voltage is 5.7 fixed, the Zener diode can never go into a breakdown region. Because for a Zener diode to go into a breakdown region, voltage should be more than 10 volt. The reverse voltage should be more than 10 volt. So from here, I can say Zener diode can never go into breakdown region. The Zener diode can never go into a breakdown region. A very, very important point to note down. It will never go into a breakdown region. Understand this point? So it means the output voltage will be 5.7 when the input is more than 5.7. So one thing we get here. Wait a sec. One thing we get here, output voltage is equal to 5.7 when input is more than 5.7. You know? So if you got this now, you can directly check what is the answer. If you got this concept now, you can directly see what is the answer. I told you this thing. When input is more than 5.7, output voltage is fixed to 5.7 volt. So the correct graph which showing this description is option number B. The correct graph which showing this description is the option number B. Understand this thing? Yes or no? Do you understand this thing? But let's do the complete analysis. Here. So one thing we have find out that when input is more than 5.7, output voltage is equal to 5.7 volt. Okay. This we have done already. Okay. Now if you talk about less than 5.7, if I talk about when input is less than 5.7 volt, so obviously in this case diode is off. That diode is off. Apart from that, Zener diode is also off. Zener diode is also off. Why? Zener diode is going to be on. Zener diode is going to be on when the input voltage is negative. When input voltage is negative, in that case, Zener diode is going to be on. And because the drop of forward Zener diode is 0.7, so it's going to be on when input is less than minus 0.7. So I can say from minus 0.7 to this. This going to be happen. So if everything is off, so the circuit will be like this. If everything is off, the circuit will be like this. Okay. So can I say here what I can say? Output voltage is equal to input voltage. I can say output voltage is equal to input voltage because there is no current flowing here. There will be no drop across the resistor. So simply I can say output voltage is equal to input voltage. Okay. Next region. When input is less than minus 0.7, in this region, what will happen? Zener diode is forward biased. But if you talk about the normal diode D, it will be reverse biased. So the circuit will be like this. We have a Zener diode here. So the circuit will be like this. Sorry. Here also. Now, can you find out what is the output voltage? Here? Tell me. Output voltage is nothing but equal to minus 0.7. Output voltage is minus 0.7 volt. So in this way, we can do the complete analysis here. If you want to draw the input-output characteristic, let's draw it. I can draw the input-output characteristic also. Transfer characteristic. This is input. This is output. Okay. So here we have minus 0.7. When input is less than minus 0.7, when input is less than minus 0.7, output is minus 0.7. When input is from minus 0.7, when input is from minus 0.7 to 5.7, output is input voltage. So here we have 5.7. So here also. So it will be 5.7, and after that output is constant here. After that output is constant here. This will be the graph you have. This is the required graph we have. Okay? Understand this thing? Next. Now before going further, let me give you one particular information that we have launched the All India mock test for all the stream of electrical EC. So you can give this particular test. It's free of cost. You just have to register for it, guys. This we have given you a test start date also, the time, the result date, and the syllabus and the pattern of exam. This will help you a lot while doing the revision, because you know the revision time has been started. That's why we are doing so many questions here. So the revision time has been started. This test will boost you and will tell you how you stand among your fellow aspirants. So don't forget to attend this particular test. Moreover, we are the test is going to be live from 11th November to 17th November. So don't forget to register for it, and you can register it on our app. So don't forget to download the app also. Next question. Next question. Now see this question again. A good question. A good question. Again, it's a clipper. Again, it's a clipper circuit. Again, it's a clipper circuit. But we will do this question by our own analysis. So we have given two silicon diodes with a forward drop of 0.7 are used in the circuit as shown in a figure. The range of input voltage Vi for which the output voltage V0 is equal to Vi. We need to find out a range of input voltage for which the output voltage is equal to Vi. This we need to find out. This we need to find out. So think about it. How you can solve this question? Simple, eh? Think about it. How you can solve this question? First of all, to solve this question, what I'm going to do? I'm going to replace the practical diode with the ideal diode. So when you place an ideal diode here, when you replace it with the ideal diode, you have to put like this. It is 0.7, and here you will put like this. It will be 0.7. It will be 0.7, right? Now minus 0.7 minus 1 give you minus 1.7, plus 0.7 plus 2 give you 2.7, right? So we can redraw the circuit. We can redraw the circuit. We can redraw the circuit like this, that we have like this minus 1.7, right? And here we can redraw the circuit like this, that we have 2.7. We have 2.7 volt, and then we have an output voltage plus minus V0. This is going to be a diode D1. This is going to be a diode D2. This is going to be our input voltage we have. Let me check. This is going to be an input voltage we have. Correct. Any doubt here? Any doubt here? Till here? Any doubt? Now what they are asking in a question, they are asking for the range of input. They are asking for a range of input for which output is equal to Vi. For which the output is equal to Vi. Now understand the situation here. Understand the situation here. The output will be equal to Vi. The output will be equal to Vi when both diodes are going to be off. When both diodes are going to be off, in that scenario, output voltage will be equal to the input voltage, right? So, for V0 equal to Vi, D1 and D2 are off. D1 and D2 are off. For output voltage is equal to input voltage, D1 and D2 are off. If D1 and D2 are off, the circuit will be like this. Okay. This will be minus 1.7. This will be 2.7, right? Here it will be plus minus VD1. Here it will be plus minus VD2. Here it will be plus minus VD2. Okay. Now let's find out the diode voltage D1. Let's find out the diode voltage D1. So if you want to find out the diode voltage D1, the condition will be like this. It will be minus 1.7 plus VD1 plus V0 equal to 0. So can I say diode D1 is equal to 1.7 minus V0. Now for condition to be satisfied, VD1 should be less than 0. For condition to be satisfied, VD1 should be less than 0. So I can say output voltage should be more than 1.7. Output voltage should be more than 1.7. So for D1 to be turned off, output voltage should be more than 1.7. Now here also we have minus 2.7 minus VD2 plus V0 equal to 0. From here VD2 comes out to be V0 minus 2.7. So for VD2 to be off, it should be less than 0. Output voltage should be less than 2.7. So we got two regions. Output voltage is more than 1.7. Output voltage is less than 2.7. So finally, if you interlink both of this region, you will find out output voltage is this. And what is the output voltage? Output voltage nothing but equal to input voltage. So here we can say 1.7. Here we can say here output voltage is input voltage now. So here we can say 1.7 input voltage are 2.7. So the input voltage will be between the range of 1.7 and 2.7. If the voltage is between this range, here you can see output voltage will be the input voltage. So let me check. कोई कैलकुलेशन मिस्टेक हुई है क्या? मैं एक बार चेक कर लेता हूँ कैलकुलेशन मिस्टेक हुई है क्या? बिकॉज ऑप्शन डी इज कमिंग द आंसर बट देयर इज अ माइनस 1.7. एक बार चेक कर लेता हूँ. माइनस 0.7 माइनस 1 इट विल बी माइनस 1.7. ठीक है, ये मेरे पास माइनस 1.7 आ गया. ठीक है, ये मेरे पास माइनस 1.7 आ गया. और D1 की बात करेंगे तो माइनस, अच्छा हाँ करेक्ट, यहाँ पर गलती होगी मेरी, यहाँ पे गलती होगी. प्लस होगा, यहाँ माइनस आएगा, यहाँ पर माइनस आएगा. करेक्ट, ये गलती हो गई. हाँ, तो ऑप्शन डी इज द राइट आंसर. ऑप्शन डी इज द राइट आंसर. ठीक है, तो ये छोटी सी गलती होगी हमारी कहाँ पर, केवीएल में. तो केवीएल ढंग से लगाया करो, है ना. सो इट विल बी माइनस लाइक दिस. केवीएल में हल्की सी मिस्टेक हो गई थी. ठीक है, करेक्ट. एनी डाउट हियर? एनी डाउट इन दिस क्वेश्चन? अच्छा क्वेश्चन है, अच्छा क्वेश्चन है. जस्ट यू हैव टू फाइंड आउट अ रेंज हियर. जस्ट यू हैव टू फाइंड आउट अ रेंज हियर. ओके, नेक्स्ट. This is your homework question. It is just like the last one. This is your homework question. If give the answer in the comment section. कोई अगर आपके आंसर में गलती होगी या कोई डाउट होगा तो मैं कमेंट सेक्शन में आपको ठीक कर दूंगा. बट ट्राई करना, अच्छा क्वेश्चन है. नेक्स्ट ट्राई टू सॉल्व दिस क्वेश्चन. ट्राई टू सॉल्व दिस क्वेश्चन. ट्राई टू सॉल्व दिस क्वेश्चन. Select the correct output V0 for a given input Vi for the clamping network given below. So we have given a clamper circuit. We need to find out the output voltage. Now output voltage is given where? Output voltage is given here. This is the output voltage waveform. Okay, so if you know the basic of clamper, you can solve this question easily. Okay, but I want you to solve this question according to the analysis we have. Okay, because in the exam, if they change something in the network, then you should know how to deal with those type of question. That's why the analysis part is very important. Okay, shortcut you know, that's very good. You know the shortcut, you can mark the answer. But analysis, I'm here to give you the teaching. You should understand how to do the analysis of that particular topic. So first of all, here you can see we have given a resistor. In a clamper circuit, if value of resistor is not given, you have to assume it is very high. You have to assume that it is very high. Why we have to assume that? Because for a clamper circuit, there is a condition. That time constant must be very, very higher than the time period. Time constant must be very higher than a time period or more than T/2. So here you can see we have a capacitor here, we have a resistor here. Since value of resistor is not given, here you can assume it is very high, so you can ignore that particular resistor. So if you ignore that particular resistor, what we got? then the circuit will be like this. We have an input voltage, then we have a capacitor here, then I have a diode here, then it is a 2 volt, it is a 2 volt here, capacitor, diode, and we need to find out plus minus V naught here. Okay, now how to solve this this particular question when you have a clamper circuit or the circuit in which you have a capacitor? How to solve this question? First of all, according to the polarity of diode, first of all you have to check in which polarity diode is going to be on. In which polarity diode is going to be on. So if you check very carefully, for the positive polarity of input, diode is going to be on. So do that particular thing. So what I am going to do, I am going to assume diode is on. I am going to assume diode is on. So since the diode is on, the circuit will be like this. Since the diode is on, the circuit is like this. We have a capacitor voltage plus minus VC. It is 2 volt. It is plus minus input voltage VI. Okay. Understand this thing. Understand this thing. Now, can you find out what is the capacitor voltage? Capacitor voltage is minus VI plus VC plus 2 equal to 0. Capacitor voltage comes out to be VI minus 2. This is the capacitor voltage. So if the input voltage is changing, the capacitor voltage is also changing. But here we need to find out the final value stored in capacitor. Here we need to find out the final value stored in capacitor. Now final value will depend on in which cycle your particular capacitor diode is on. So you can see diode is on in positive half cycle. Diode is on in positive half cycle, yes or no? Diode is on in a positive half cycle. So what I do, I will put the VI max here. In a positive half cycle, I will put the VI max here. So what is the final capacitor voltage? What is VI? What is input voltage? The input voltage is, let me check. It is 10 volt. It is 10 volt. So VI max will be how much? VI max will be 10 minus 2. VCF is equal to 8 volt. Okay, understood? This is the final capacitor voltage. So what you have to do here, first of all, you have to assume diode is on and you have to check in which cycle is going to be on. It's going to be on in a positive half cycle. Then you will get the equation of a capacitor voltage. That equation you got here. Okay. Then you have to find out the final capacitor voltage. Now final capacitor voltage is based on in which cycle your particular diode is on. Diode is on in positive half cycle. So that's why we have put VI max here. Okay. So if it is on in the negative half cycle, we have to put VI minimum here. So it will be 10 minus 2, 8 volt. After that, what you have to do? After that, what you have to do? Now you have to take, now you have to assume diode is off. Now you have to assume diode is off. Okay, these steps are fixed. For the clamper circuit, bacho, these steps are fixed. So I'm going to assume that diode is off. So if diode is off, can I find out the output voltage? The capacitor voltage will be fixed. The capacitor voltage is going to be fixed at VCF. Remember this. Capacitor voltage is going to be fixed. And why? Because we have taken a particular case earlier. We have taken particular assumption earlier that time constant is very, very high. When the time constant is very high, the charging, discharging will be very less. So that's why the capacitor voltage remain constant. That's why capacitor voltage remain constant. Because of that particular reason. So here I can say, what is the output voltage? Minus VI plus VCF plus V naught is equal to 0. So output voltage comes out to be VI minus VCF. Output voltage, it comes out to be VI minus VCF. Okay. Now what is the input voltage? Now what is the VCF? VCF is equal to 8 volt. VCF is equal to 8 volt. Let me check. VCF is equal to 8 volt. Right. So thus question is complete. You got the equation of output voltage. You got the equation of output voltage. So here I can say, what is the input voltage with respect to time? The input voltage is this. Input voltage with respect to time, it is 10, it is minus 10. What is the output voltage then? What is the output voltage then? We have VI minus 8. Sorry. We have VI minus 8, right? So if you subtract here, if you subtract the 8 here, it will be like this. It will be like this. What is the point here? It will be 2 volt. It will be minus 18. It will be 2 volt. It will be minus 18. So which particular option is correct? Which particular option is correct? इतने कम अटेंडेंस देख के ना मुझे लग रहा है कि कल से क्लास बंद करनी पड़ेगी. फर्स्ट क्लास में तो आपकी अटेंडेंस होती है, फिर आप कहते हो कि सर एनालॉग के क्वेश्चन करा दो, है ना, तो फिर इतने कम अटेंडेंस रखोगे तो हमें क्लास फिर बंद करनी ही पड़ेगी. Okay. Now, before going further, let me tell you that you can download our app, which is a BYJU'S exam prep app. In this app, we are taking many free classes. You can join that class and boost your particular confidence and the revision of subjects also. In that particular app, we are also analyzing the quizzes in our session. In the quizzes, you will get this type of a score and you can compete with your fellow aspirants. This will help you a lot in your revision practices and you will get to know कि आपको कितना आता है, आपको कितना नहीं आता है. And do practice a lot because daily इसमें पर quizzes होती है, daily आपकी free classes हो रही है, so आपको अच्छे से आपकी revision practice यहाँ पे हो जाएगी. So don't forget to download our app BYJU'S exam prep और जो workshops वगैरह भी होती है वो आपको यहाँ पर आ जाती है. Okay, now this is I'm going to give you a homework question. Simple है. This is a simple question. Give you the homework one. Okay, next, try to do this question. In the figure is given on next page. D1 is a real silicon PN junction diode of a drop 0.7. D2 is a Zener diode with a breakdown voltage of minus 6.8 volt. The input voltage is a square wave. Assuming that 10 tau is very less than t, where tau is the time constant, what is the maximum and minimum value of an output voltage waveform? So what is the maximum and minimum value of an output voltage waveform? So this type of circuit we have given for a diode D1, they have given it is 0.7 volt and the Zener diode is given 6.8 volt. The Zener diode is given 6.8 volt. We need to find out the maximum and minimum output voltage. We need to find out the maximum and minimum output voltage. So try करो, बताओ क्या आंसर होगा. At least try to make a circuit for output voltage or a maximum voltage, input voltage, जिससे कि आपको ये पता चले आप सही path पे जा रहे हो. So that you get to know that you are moving in a right path. Okay. So options are also given. Options are also given. And one more condition is given. 10 times of tau is very less than t. This condition is very important. This condition is very important, which is given here. 10 times of tau is very less than t. Okay, so try करो कैसे होगा. Ten times of tau is very less than t. Now here, see one point very carefully. See one point very carefully. This line means that charging and discharging of capacitor is fast. This means charging and discharging of capacitor is fast. Charging and discharging is fast. Means depend on not both are fast, not both are fast. Depend on कि resistor is not is present or not. So charging and discharging is fast. This particular point is given here. It means in this scenario, capacitor voltage is not constant. Capacitor voltage is not constant. This means capacitor voltage is not constant. Now understand one point. For clamper circuit to work, the capacitor voltage must be constant. That's why time constant is very higher than the time period. But here the time constant is very less than the time period. Now how to solve this question? So first of all, to solve this question, you can see first you have a positive half cycle. In a positive half cycle, what can happen? Directly we have a 14 volt. What can happen? We can say diode D1 is a forward biased. We can say diode D1 is a forward biased. And if you talk about Zener diode, then Zener diode is in breakdown region. Zener diode is in breakdown region. Can we directly say like this? Can we directly say like this? Because in a positive half cycle, it is a 14 volt. So if you draw the circuit will be like this. If you draw the circuit will be like this. Okay, I'm talking about the steady state here. Remember this. I'm talking about directly steady state here. I'm not talking about the transient state. There will be a transient state also because the capacitor will keep on charging. Capacitor will keep on charging. So there will be a transient state also. So it is 0.7, it is 6.8. So here you can see output voltage is fixed at 7.5 volt. Here you can see the output voltage is fixed at 7.5 volt. That's okay. That is the maximum voltage we have. That's the maximum voltage we have because you cannot get the voltage more than this. Once it is fixed at 7.5 volt, capacitor voltage can also find out. Capacitor voltage is equal to input minus 7.5. So it is 14 minus 7.5, it will be 6.5. So in a positive half cycle, capacitor will be charged up to 6.5 volt. In a positive half cycle, capacitor voltage will charge up to 6.5 volt. Now what happened? When it is a charging mode, one thing you can see. Now what happened? When the negative half cycle will come, diode D1 will get reverse biased. Diode D1 will get reverse biased. So obviously diode D1 will be off. Obviously diode D1 is going to be off. And Zener diode will be in the forward region, but there is no use because diode D1 is in series, it's going to be off. So what will happen here? You can see when you're going to a negative cycle, as soon as negative cycle starts, what will happen? Diode D1 is reverse biased. Diode D1 is reverse biased. Then you have a Zener diode, you can show like this. Then you have a Zener diode that you can show like this. Is plus minus output voltage. This is capacitor plus minus input. Now what will happen? Discharging will also start. Now here you can see capacitor is directly connected to a resistor. So what will happen? Discharging start. What will happen? Discharging will start. So discharging will start means capacitor voltage will keep on decreasing. The capacitor voltage will keep on decreasing. Earlier, capacitor has been charged to 6.5 volt. But now its voltages keep on decreasing. But what we need to find out? Output voltage. So can I say output voltage is minus Vi plus Vc plus V naught equal to 0? So can I say that particular output voltage is equal to Vi minus Vc? Output voltage is equal to Vi minus Vc. Now what will be the minimum output voltage? Minimum output voltage is that when the capacitor voltage is maximum. Minimum output voltage is when the capacitor voltage is going to be maximum. That will be a minimum output voltage. Now input is fixed. If you see the input waveform, input is fixed at minus 14. So input is fixed at minus 14. Maximum capacitor voltage is actually 6.5 because after that it keep on decreasing. So it comes out to be minus 20.5 volt. So we got two voltages. The maximum voltage here is 7.5. The minimum voltage here is 20.5. So maximum is 7.5, minimum is minus 20.5. So option A is the right answer. Okay, understood this question? अच्छा क्वेश्चन है अगर आप इसको ध्यान से देखोगे. It's a nice question if you see it carefully. So before ending a session, let me give you one information that we have already launched our crash course for the GATE 2024. So if you haven't enrolled in this crash course, this is the right time to enroll it so that more and more practice you can do. Okay, in this crash course, we are providing the live class, recorded lecture, study material. So don't forget to enroll in it. Okay. So bye guys, take care. See you tomorrow with the questions based on rectifier. So don't miss that particular class.